Good morning. All right, we are going to cover 26207 on today's lesson. So I'm going to share my screen with you guys real quick, and that way we can go ahead and get started. Let's see here. Okay, I'm trying to move me out of the way over here. That way I need to see that. All right, so today's going to be talking about cable trays. Let's see. I thought I could make this. There we go. Cable tray components. Identify cable trays. Looks like it's moving. All right. Select cable tray fittings. Identify cable tray supports. All right. This illustration here is nothing more than an overview of all the various different types of cable trays. You got these over here going vertical. You got horizontal solids. You have open. You have elevated, vertical adjustable splices. So just give this table here a good look over, just to kind of get an idea. You see this side over here is a louvered covered type of cable tray. And they're used to support wiring systems for not only industrial, but the commercial applications as well. So, but they're primarily used for industrial. The whole purpose of having cable trays is to allow a versatility. So if you're moving equipment quite frequent, it would make sense to run hardwired into conduit and so forth. So we got to make sure that the proper, if you move your equipment around, it's easy enough to just move the wiring around. So lay it in and take it out of cable trays. So let's see here. All right, so what we're looking at is if I have a cable tray and I'm actually looking down it as if though, in this scenario here, follow my mouse here, there'd be cable here, cable here, cable here. And it's just sort of like looking at it from the end view. Cable tray dimensions, they're going to vary depending on their design. They have certain fill requirements because you can't overload them. There's another example of your cables laying in the cable trays. And this is if their cable needs to leave the cable tray and actually get hooked up to, say, a motor or a piece of equipment and so forth. Pay good close attention here. I'm going to see if I can't zoom in. I don't know if I can or not. There we go. So as you can see up here, we have right here is where it actually transitions from the cable tray and goes down. You have to have that. It cannot just go over the edge and drop straight down. So, and then this over here is a different type of, so if you actually go away from it and then drop from there, notice how it gives that contour right there. It says conduit, bracket, and clamp. And this is obviously conduit here. Once again, you want to support and protect your cable from direct 90-degree turns. So let's see if I can back that up now. There we go. All right. Maybe one more. Let's see. There we go. Okay. All right. So we talked about yesterday about the shunt device used to facilitate a cable pull on a tray. They got pulleys and cable rollers that can facilitate pulling conductors on a tray. Cable tray covers are used to protect objects from falling onto the tray and protect conductors from the harmful UV rays. Now look at the different ways that which cables may exit from a cable tray. Obviously I have vertical up, vertical down, and even on that drop out from the end, it has to, it can't be a direct 90. You really got to protect that. Of course, you scroll down right here, you have your dropout plate, dropout between the rungs, over the side, and so forth. But you definitely, like I said, you got to make sure that you protect your cables. So, all right, let's close that out. Dropout plates, obviously what we discussed. Here's a perfect example of vertical runs. And we're going to zoom in right here. You notice that these are all wire ties or zip ties. And the whole purpose of those should be to carry the weight, to assist in carrying the load of the weight of the cables. So I like the way that they zip tie them every other rung. So approximately every 12 inches they're being secured. Fabricating a cable tray offset with the swivel plates. The type of splices, splice plates include vertical, horizontal expansion. The vertical splice plates are used to change the elevation in a run of a cable tray. They're created to using for swivel plates as shown in the illustration there. Expansion joint and splice plates. So if we're going to connect multiple plates together, we got to make sure that we put the proper splice. So this is looking at from a side view right here. So we're actually adding plates across there so as to connect them together. And obviously this one here after the expansion and so forth. So, all right. These are different ways to hang it, known as trapeze, wall mounting, direct rod suspension, center. So those are just different methods. Cable tray supports. If you'll zoom in right here with me. All right, as you can see, they've actually anchored the all thread all the way to the purlings of the building. This here is unistrut. So they've actually just used this piece of unistrut as support and then supporting it through the use of all thread. This here's just center rail cable system. The cables would literally run, let me see if I can find my mouse here. Let's try it again. Let's see. There we go. So your cables would literally run horizontal or parallel with the center and the sides here. They'd actually run inside. So describe the purpose of each component that is called out during the exercise. All right. All right, so we're going to go ahead and move right into the second one here. Let me exit out of this and bring up the second one here. Of course, just a reminder, anytime you have a question, please just write the question down. You can send me the question through Edmodo, message it to me, and then I'll be glad to find time to do an open discussion with you if you need to, or if you just have specific questions, definitely move in that way as well. So let me share this screen with you real quick. All right, so this is part 2. So we're going to calculate the load on a cable tray, determine the load on supports, identify the types of failure under load, and identify the installation requirements for cable trays. So we're going to generate a list of materials for a cable tray layout, list all the components required, including fasteners required to complete the system, and join 2 straight ladder type cable tray sections together. So load capacity of a cable tray varies by manufacturer and depends on numerous factors. Identify at least 5 of the factors. It's going to be the shape and thickness. Obviously I went ahead and clicked on it so they're right there before you. Shape and thickness of the bottom members, spacing of rungs, material used, safety factor used, method used to determine the allowable load, and method to supporting the cable tray to volume capacity. Now, obviously, we're talking about the load. We're talking about the actual weight. How much weight is each cable tray available to carry? So this is talking about cable tray loading. The load capacity of a cable tray depends on the many factors, including the shape and thickness of the side rails of the bottom members, rung spacing, support method, and type of material. Refer to the cable tray manufacturer's capacity information. Cables must be packed loosely in tray to avoid overloading and loss of efficiency. Determine the load on supports. Each support must be able to withstand 1 1/4 times the full weight of the cable tray. Excess loading will result in deflection of the side rails and the bottom tray, the potential failure of the cable tray system. So the math here is uniform load of tray and cable equals the full weight and tray of cable over total lineal feet. Two types of cable tray failures, obviously going to be longitudinal and transverse. Longitudinal failure occurs in the bending failures and buckling failures. Bending is more likely than shorter spans, while buckling occurs over long spans. Load of a cable creates bending moments along the span. When the stress in the side rail is directly proportional to the bending moments of all points along that tray. Splices are points of weaknesses and should be located within 1/4 of the span distance from the nearest support whenever possible. So this here is just an illustration showing the weakness between your splice and support. You really just want to make sure that you're not overloading your cable trays. Just know that wire weighs. I mean, I know if you're handling a piece of Romex, you're like, that's nothing. But some of these cables, they're big cables, and this copper, and it's, you know, you're looking at close to like 6 pounds per foot per conductor. You multiply that times 2 or 3, and you know, you're looking at 18 pounds per foot. So it could get heavy. All right. These are some NEC requirements. Welding cable may only be installed in dedicated cable trays. So if you're using powering up a welder by the use of cable trays, there's specific rules involved in that. You can find that in 630.42. Where conductors number 1/0 through 4/0 are run in a ladder type trays, the maximum rung spacing cannot exceed 9 inches. As you can see in the illustration, that the bending and weight of the wire could cut or be, especially if it starts getting hot. If you start overloading it and it starts getting really hot, it could create situations where the wire itself starts bending down in between the rungs and creating issues in that manner. So there, and so forth. Please continue to read through the rest of these. They're in your book. Let's see here. Regulations governing cable tray construction. Once again, these are important reads. So, for example, cable tray must include fittings or other suitable means for changes in direction and elevation of the runs. I'm not going to go through all these for you guys. More than capable of reading them out of your book. All right. More cable tray governing. Got to bond it. Anytime there's a steel building, you have to bond it. Still, even if you're looking at these right here, says steel or aluminum cable tray systems are permitted to be used. It's got to be bonded and grounded up here, as you can see in that illustration right there. From beam to beam, minimum cross-sectional area of a cable tray must conform to these requirements. Yeah. These are just different designs. Cable tray systems are carefully engineered systems and must be installed per the specifications and work drawings. All right. Okay. So let's see. We got one more. Let's see here. Determine cable tray fill, determine the number of conductors allowed, and identify the derating factors for cable tray conductors. So obviously, let's take a look at this picture here. That would be an overload, an excess of conductors in a cable tray. That's ridiculous. That was kind of ridiculous to even have that slide there. So if you have any questions or concerns when it comes to cable trays, before we wrap up here, we're gonna walk out here. And we're just going to look real quick at the ones we have in our lab. So you guys can see. This is the ones that we've had out in the lab. You guys have all seen them. As you can see right here in the center, we have the, oh, wrong one. There we go. There it is. The center mount trapeze. And they have their bonding plate. Oh, there it is. There it is. Where they're connected to each other. So, like I said, if you have any questions or concerns when it comes to cable trays, they're not really hard. It's not a challenge. The toughest part of the cable tray system is actually just installing them, mounting them, laying them out to where they're conducive to what you're looking for, and so forth. So if you have any questions, like I said, just reach back to me and we will collaborate. So have a great day.